So the topic I want to talk about today is the future of professional, let's say, audio processing in the web as a platform. Before we start, few words about myself. I'm Vitalii. I'm a lead software engineer at a company called EPAM Systems. I'm working in Poland, a city called Wroclaw. And at my free time, I'm experimenting with web audio, especially in terms of processing guitar sound. I also organizing Angular Wroclaw meetups, and before COVID, talk a lot tech conferences offline. Now it's only available online. Unfortunately, you can follow me on Twitter or read my blog post. And today I must admit that I have a problem. A real problem that I love pedals. As I said, I love pedals in web audio, like in web browser. Also, I love pedals in real world hardware, these metal things with LEDs. And I love to build pedals. And right now I started to even design my own PCBs for pedals. And it's a problem. It's a real problem. Know you or not, you heard most of popular pedals even if you don't know them. Why? Because simply they are on literally every record that you heard, like classic rock or even pop or hip hop. All of these recordings are full of different types of effects. And it's not only analog ones. Right now, in studios, people combining both digital, analog, software, and everything is combined into a single recording, and you get the final product of it. If you're speaking about analog, it's mostly about some kind of dirt effects or amplifiers for instruments, but digital and software are really good in some effects like reverberations, delays, and things like that. They can create a real underneath atmosphere of a track with some kind of ambient reverberations and things like that. So every one of you, if you ever listen to music, you heard a lot of digital and analog effects. And today I try to touch the topic how studios could use web audio for their professional performances and what actually stops them to do it right now. First of all, let's dive a bit into web audio history. The first draft proposal was released in 2010, and after 2 years, in 2012, there were initial implementations of these specifications. First, it was in Chrome-based browsers, then it was Firefox, Safari, and etc. And web audio as a standard right now includes a bunch of number of audio nodes which you can use to compose them into graph to process or generate music. Personally, I feel that all these standard nodes was inspired supposed to be used by people who are synthesizing music, like synthesizers, digital music, and things like that, but not much regarding processing instruments or voice in runtime. And the biggest limitation that we can't actually extend those nodes or use something low level to process the audio stream, because how it's done in desktop applications, you working just on raw audio buffers and just managing numbers of these buffers, and that's it. You can do whatever you want with just those numbers. But in web audio, when it was initially released, it was only high-level nodes available, like wave shapers, some kind of filters, and things like that. And if we're going to speak about choosing a technology for digital signal processing, DSP, actually web audio is really young comparing to those giants written in C, C++, and things like that. So they are really mature in comparison to web audio. What technologies actually used for digital signal processing in desktop applications and things like that? Most of them are written in C, C++. There are some substandards for writing those plugins called Juice, iPlug, LV2. And if you speak about hardware, digital effects, most of them are using assembly because they run in some small DSP processor that runs this assembly effects written in assembly on their small processor, so they want to be as performant as possible and as close to their hardware as possible as well. What are the main stoppers to use web audio for development professional software? The first one is latency, because browsers have additional abstraction layers on top of system calls to audio stuff. And second thing, that we can't work with raw audio stream data like it used in classic desktop digital audio workstations, DAWs, and DSPs plugins. But a few years ago, there was introduced a new API to web audio called Audio Worklet, and it actually solves most of problems regarding the latency. How it looks like? Audio Worklet node is just same audio node as any other, but you can provide your custom implementation. So it's exposed you a possibility to create custom audio nodes using your own code and work with audio buffers. So there is a audio worklet property on audio context, and you pass in a path to your worklet code. Worklets should be written in a separate file or should be converted to a separate file, because this code is supposed to execute in special audio worklet context outside of your main thread that gives you actual this performance, because it's executed in separate thread dedicated for audio processing. So no UI interactions will stop this processing and things like that. Then you actually creating an instance of your custom node that could be used as any other, so you can connect it to other nodes, to destinations, to streams, and things like that. How Worklet looks like itself? It's just a class that extends interface audio worklet processor, and there is the main method for audio processing called process. And as an input, this method receives inputs and outputs, which contains all channels available, audio channels available in your system right now from your device. And each channel contains a small amount of data related to current audio stream chunk. So it depends on bitrate of your device and things like that. For example, if it's 44 kilobits, that means that your buffers will be 128 items in each of them for each channel. And optionally, you can pass some parameters to adjust your effect in runtime. Those parameters should be defined in static getter, parameter descriptor, and it should return a list of all available parameters for your audio node. And they actually have the same shape as standard ones. So you can provide a name for it, default value, and limit it to min and max value. Then you have a global function in audio worklet context called register processor. And you should just pass your implementation and name into it. So how it actually solves the problem? It allows you to work on raw audio buffers like it's done in DSPs written in C++. It executes in separate audio thread, and it acts as any web audio node. So it's easily could be connected to any source or other nodes in your web audio graph. So audio worklet, it enables you to write no latency, almost no latency audio processing in your browser. It's extremely fast. What about browser support? So all Chromium-based browsers are supporting audio worklet for a long time, for a few years, and Firefox just moved this API out of FLAC to be publicly available a few releases ago. The only modern browser that can't actually run audio worklet is Safari, but it supports deprecated API called script processor node. It's kind of similar, but it runs on the main thread, so you won't get the same performance with it, but you can use it as a fallback to get it work in Safari. So as I said, audio worklet gives you a full freedom to create any custom audio processing node you want. And it's really, really cool. But if we want to gain even more performance while processing, because audio processing usually involves a lot of mathematical calculations, like additions, deletions, getting sinus, cosinus, and things like that. And WebAssembly actually is a great candidate for such a mathematical operations. It could do it as low level as possible in browser and run your code performantly. So for web-based digital signal processing, we can actually use C and C++ with help, for example, of mscripten, and this gives us ability to port almost any DSP that was created for desktop applications into web, and this is really cool. We can use Rust, or we can use some domain-specific language for DSPs like Faust. I will speak about it a bit more later on during the talk. So WebAssembly enables a great performance and enables a way for professional digital audio workstations to be available in any browser. So more and more professional software will be available just in your browser. But what is the still missing piece to give extensibility and portability for audio plugins in web is actual no plugin system in a standard. What I mean, desktop digital audio workstations have a bunch of standards like VST, Apple audio units to be used as a plugins. And usually plugin developers write their code in C and then create their plugin to be available in few of most popular plugin standards. So you create the plugins and wrap it in VST and Apple audio units, whatever, and it's available everywhere. But for web, it's actually even easier because all of it is just JavaScript or JavaScript and WebAssembly, so there is no issues in portability in case of language standards, but there is no standard actually. There is no one way to create a plugin that could be used in any web application that uses web audio, and it's a big miss. And there is actually a few tries to create such a standard, and one of them that I want to speak about today is called web audio plugins. So what is web audio plugin? It comes as SDK and interface to create your plugins. SDK is supposed to be used by host applications that could load and use plugins, and plugin interface for actually plugins. So it looks like any other node creation. So you need to know the symbol of your custom node, pass it audio context and URL to plugin itself. Then you call in load method on this plugin, and you get an audio node that could be connected into your audio processing graph. And optionally, web audio plugin could came with its own graphical user interface. It could be a web component or something framework specific. So you have an instance of audio effect to be included in your word graph, and actual element to be inserted in your DOM to control parameters or bypass of your plugin. So how it helps to make extensions for web audio. The cool feature is that it's just accessible by URL as any other resource on the web. So you don't need to download any plugin manually. You just need to pass URL, and here we go. It uses WebAssembly and audio worklets for integration and gaining the most performance you can, and web components for graphical UI. And there is a language that I mentioned before called Faust, and it could be compiled to WebAssembly and then wrapped into web audio plugin. So this language, actually, its name stands for Functional Audio Stream. It could be compiled to few actually languages like C++, WebAssembly, LLVM, Bitcode, and it comes with a really big helpers library for working with filters, working with oscillators, and things like that. So it's really rich and gives you a big power to work with writing DSP code. And it could produce both DSP code, your effect, and UI for it. So even more, you can use online Faust IDE to fastly prototype, create, and publish your plugins, and they will be immediately ready to use in any host application. And basically, it's all about speaking, and it's demo time. If everything will work as I hope, let me switch to Faust IDE. So here we have the actual IDE. I loaded the first one file from examples. It's a zeta reverberation plugin. As you can see, it builds a graph of this plugin, how it's processed. So we have two channels for stereo, left, right, and wide dry signal. So it's splitted into unprocessed signal and signal with an effect. And it runs through our reverberation algorithm, then mixed back, and we have output level control. So we have a graph, and in this IDE we can actually compile it and try and write in a browser and test it. So I hope it will work. Okay, yeah. So it's compiled. Here you have controls for this effect, like level, output level, mixing unaffected signal with effects, and some controls and parameters. And we can actually test it right here using real instrument. Yeah. So let's try to do that. If it will work, as I hope. Okay, we running. Yeah. Okay, some signal come. Yeah, and you can listen this kind of ambient reverberation. This is just a DSP that available from Faust standard library. Another example I want to show, here I'm trying to port a chorus effect from open source guitar amplifier emulator called Guitarix. And it's open source, available for Linux, and pretty cool open source software for guitar. And not most, but a lot of effects for this program is written in Faust. So you can easily grab and try to port them for web. As you can see, there is some descriptors for your plugins, like name, category, things like that. Then you can import libraries from Faust or your own. Here I'm importing some plugins available in Faust library. If I need any other library, I can add it as a file here right in IDE, like that. I can write Michael Leap. And use it here for another DSPs. I can create another effects, all of them available to run here. So let's, and actually over internet, there are a lot of open source effects written in Faust, and it's actually easy to write your own. You need to get used to its special syntax, because it's syntax that describes such kind of graphs. Let me run it. I need to switch here. Yeah. So it's a syntax that used to describe a graph. You can create the functions and then use with blocks to specify input parameters for those functions. It's not really similar to any language that I used to write code in, but it's kind of easy to get started. You just need to get initial idea how it works. And you can see this chorus is written in like 30 lines of code, and just using few things from the library. And as I said, Faust allows you to specify not only the DSP code, but controls for it. Here you can see H slider, which stands for horizontal slider. You specify which parameter it will control, and range and default value and things like that. Yeah, and depending on this configuration of controls, here you have your controls, default controls right here in IDE. So let's try to run this one and check if it actually works. Yeah, it's chorus. My signal might be interrupted because I'm streaming right now, so my audio card might not able to handle everything. After we actually check our plugin, if it works, if we like it, we can create a basic UI for it right here. There is a hidden setting to enable experimental web audio plugin interface builder, and the URL where it will be published afterwards. So we have pretty primitive editor for user interface where we can drag our controls, change labels, fonts, and things like that. For example, here we selecting this label, we should make it Comic Sans. We can choose some crazy backgrounds for our effect, like this one, pretty sweet. And then we can actually publish it to remote server. So it compiles Faust to WebAssembly, add JavaScript glue code, wraps it inside audio worklet, and uploads to server. Yeah. Alternatively, we can download our DSP files or export them, compile them. For example, as you can see, there are a bunch of platforms available. I'm using web, which means that I'm gonna to use web audio plugins, and I can compile and download the archive with this plugin. Afterwards, I can choose if I want to include this plugin at compilation time at my host application, or I can just use a link to this plugin to be used in any other application. So it's literally just a few minutes for you to prototype your plugin and create basic UI for it, which you can later make more perfect without that much images, and just simply import it in your application. Right here, I'm still working on integration. I have some issues with my own dependencies and how SDK patches the context to work. But you just need to pass URL and use it in any application. There is available plugin tester because your plugin specifies metadata, which includes its name, category, and things like that, whether it has UI and things like that. And you can afterwards test it. This metadata test the plugin, just providing a link to it, like this one, for example. Build, and you get the UI, and you can run it in your browser. Here's an unaffected signal. If you turn on this effect, you can see that it's processing everything. So Faust gives you a pretty fast way to build very performant web audio plugins. That's everything that I have from my side. Slides are available on Speaker Deck, and I will share a link on my Twitter later on. If you liked this talk, give me a follow, visit my blog, and get your hands dirty and try to build some cool effects with Faust and Faust ID and publish them and share it.